Okay, in section 2.8 we're looking at related rates, and related rates are similar to implicit differentiation. So for now we're thinking of, you're given an equation and you're thinking of all the variables in that equation as implicit functions with respect to time. So you're going to be taking the derivative with respect to time instead of respect to one of the variables in the equation. And the reason they're called related rates is that the variables are related by this equation, and you get the rate of changes that are also related by a similar equation. So let me just do a quick example. In example 2.26, a retail store estimates the weekly sales S and advertising costs C are related by this equation. S equals 5,000 plus 50C plus 0.25C squared. Currently, the weekly advertising costs are $2,000, and these costs are increasing at a rate of $100 per week. Find the current rate of change of weekly sales. Okay, and so step one says define which quantities are given and which quantities are to be determined. So we are given that the weekly advertising costs C are $2,000. So what's given is that C equals $2,000, and that that rate is increasing. So that's the rate of change dC dt. So the rate of change of the cost is increasing at $100 a week. It's a constant increase. So dC dt is 100, C is 2,000, and what we're left to find is the rate of change of the weekly sales, which would be that'd be dSTT, is to be determined, TBD. Okay, so these related rate problems are all like this. You're going to be given some quantities and you're going to be looking for one of the rates of change. In this case is dSdt. Now to find dSdt, we need to apply ddt, the derivative with respect to time, to this whole equation. So it's ddt of S equals 5,000 plus 50C plus 0.25C squared. And again, because the derivative respects addition, we can do ddt of S, we can do ddt of 5,000 plus ddt of 50C, and then plus ddt of 0.25C squared. Okay, and so we're thinking of each one of these things implicitly as a function of time. So S is a function of time and C is a function of time. So we get that ds dt is equal to the derivative of 5,000 is 0, plus the derivative of 50C is going to be 50 times dC dt, again because you're applying chain rule. So you're thinking of C as a function of t, you're applying chain rule. So you get the derivative of 50C with respect to C is 50, and then you multiply by the derivative of C with respect to time. And then the derivative of 0.25C squared is going to be 0.5C. So that's the derivative of 0.25C squared with respect to C, and then you multiply by the derivative of C with respect to time. Okay, so this gives us an equation that relates the rate of change of ds dt to the rate of change of dc dt and to C. And so now what we do is we plug in the given values into this equation, and that'll give us ds dt. So ds dt, once I plug in these values, ds dt is 50, and then dc dt here is 100, so that's 50 times 100 plus 0.5, and we were given that C was 2,000, so it's 0.5 times 2,000 will be 1,000, and then we're also multiplying by dc dt again, which is 100. So ds dt is going to be 5,000 plus 1,000 times 100, which would be 100,000, so it's going to be 100,000, or 105,000 is the rate of change of the sales with respect to t. Okay, so again, that's what we're looking for, is find the current rate of change of weekly sales, and with this calculation we see that the rate of change of weekly sales, ds dt, is $105,000 a week. So our sales are going up $105,000 each week.